Okay. Are we back? I hope we are. My apologies. Technical difficulties. Mild technical difficulties. Okay. Auto bed leveling, splendid. Now, we need to wait for Danny to finish the print yet again. This is still going. So yeah, like Danny. And in the meantime, how long is it gonna take? 17 minutes, not bad, could be worse. That's actually about perfect time for me to get the move on the animation. We also should start working on the physics video. And there's also going to be another one. But first, this animation. Right here. Right here has to be foreshadowing, because I'm still waiting for a couple of animations to go there. Brilliant. There we go. In this case, what I need is another file. Brilliant. Then, absolutely demolish all of my progress so far with all these. That is no longer necessary. Keep the focal point, that's kind of important. Remove this, remove this, remove this, remove this, remove this, remove this, remove this. Absolutely all of them can in fact go, because all we care about is the data pin. In case some of you all have been following up on my live streams and actually watching them, you may know how the WS2812, I'm pretty sure it's WS2812, but how this LED works. And effectively we just have a single data line over which we send all of the data. Now this is quite unusual as far as normal electronics go, simply because normally you would have some kind of I2C or SPI or whatever. The point is, well, actually, does SPI have a clock? I think SPI has a clock. I've never used SPI. I'm getting wildly off topic. SPI data standard. Synchronous. It is synchronous. Clock. Okay, so it is using clock. SPI, I2C, what else is there? Doesn't matter, the point is they all use clocks, and the reason why they all use clocks is because it's a great way to synchronize data flow, you know? If one device has a clock, if the other device has a clock, then you can just synchronize data between them, and then you can figure out whenever something is sending a bit, a byte, whatnot. In this case, however, we do not have a clock line. Instead, we have a single line that is a data line. And then, effectively, What that means for us is that we need to keep them synchronized statically. Which means going through the datasheet and figure out how all of the timings go. How am I gonna represent that though? Well, I mean, first things first, we could just open the datasheet for WS2812 datasheets. There it is. Okay, in this case what we need is a completely new set of geometry nodes. And David, how you doing? Hold on, if you don't mind, I would... There are a lot of machine noises in the background, it just hit me. But I promise they are all important and crucial to to my work, alright? They are all doing important things. So basically, we're going to create geometry nodes which look like this. They will be... I don't think we need the plane. Yeah, no, we won't have the plane. Instead we will have axes, which will be a cylinder. Right, I'm thinking of what's the best way to do this. I could do it using shader nodes, which would be slightly more prone to failure, but at the same time possibly better with performance, and also possibly way easier to use. I could also do it with icospheres, that's slightly dumber. Or I could do it with curves. Well, that's a good idea, actually. Alright, transform, we need two of them. Like this, join geometry. Not right here, only after the transform. We need to transform as well, like this. And then rotate this one by 90, rotate this one by 90. Value for depth, value for radius. Roughly this size. Hi there, Alan, how you doing? Right here we might as well just turn off the glow for now, which means we're going to do 410 and clear keyframe 0, and right here this just appear into existence. If anything, we would like this to be shifted even more to the right. Clear the keyframes, they absolutely don't matter. And this, all math, math multiply. I guess it doesn't matter which one we multiply, but I'm going to multiply this one. Simply for the sake of convenience. Splendid! Will this be Schizophrenia Premium? No, I will... Listen, trust me, it's gonna talk about, alright? It's not just in my head this time. At least I think so. I don't know how we do it. Speaking of, actually... Yeah, we do need to... We've been over this, it already talks to me like the Green Goblin must. CD... Q... Workshop long-term mask code. Fix it. Codes. Okay. Listen. Okay. That was my argument, yes. That metallic clank, that was my entire argument, that's my point. So with that argument, I don't think in good faith you can disagree with me. But the point is, this. If we do Python basic speech recognition and run this sucker, then it's gonna take a while in order for it to initialize, in order for it to start all the things, because you know it has to initialize one thing, then another, and yada yada. Just give it a second. Don't mind me, by the way, I'm eating dinner. Haven't eaten much the whole day. As well, to be fair. Yeah, exactly. There we go. I know it's really tiny and really small, but at the bottom of the screen you can actually see what I'm saying in text form. And so this will be Fixit's ears, actually. This will be what Fixit will be using. Well, that's not quite right. This will be more like, you know, voice processing. Because what actually will be ears is this little module right here. And that is the microphone. And so the point is, right now, all I need to do is just actually not finish, but wait for this 3D print to finish, which will take, wait, 20 minutes or 17? Make up your goddamn mind. It said 17 at the very beginning. I no longer trust it. Whatever, 34, like 60, 56% out of 31 should be 17, so that's 17 minutes. Then the front will be finished, and then we'll be able to assemble the mask. We'll be able to just move the code onto the mask, and then 3 minutes slave break for lunch. I'm hungry, alright? Sue me if you need to. I'm hungry, and there is nothing better I can do. Listen. Also, hold on, I need to turn off the program. Terminate. Not terminated, you bloody idiot. Terminate. There we go. See, it turns itself off. How convenient. Alright. That's great. You know, I am hungry. I'm hungry, I'm making it. Oh my goodness. Okay. Let's add more commands. In this case. We're going to improve it better later on. But first things first. Raspberry Pi Python thing control. Now, I know how to do it with MicroPython on the Raspberry Pi Zero. The question is it the same on the Raspberry Pi? Did I say Zero? I meant Pico. Already have everything, trust me. I've already done and see. Oh no. RPI, GPIO as GPIO. The issue there is that we obviously cannot test it on my computer, because my computer doesn't have fins. So instead what we're going to do is... Oh, there it is. Give me a second, I know I put the USB adapter. Why does it always have to be something? I was just kidding, by the way. I knew exactly what I put the USB adapter. How did you mix up all matter and math earlier? What do you mean? This is our power, which means that all we need to do is just plug it in. Normally I would assemble it first and only then plug it in, but well, we might as well do both for now. It's on. It's running. By the way, all of the cables on it are not for aesthetic reasons. That is my genuine soldering work to connect it all together. Oh, matter instead of math, were you connecting something in Blender scene? Was I meant to say math? What can I tell you? I'm clearly mental, Alan. I don't feel like I need to explain that much. I am mental. Have you seen me? I talk to my mask. And soon it's going to start talking back. I don't think we need to get over this. Hold on, because first things first, I need to connect to my mask, which is a sane sentence that a sane person would say. That's my password, right, there we go. It's running. And then what we're going to do is we're going to... Really. So, first things first. Pins. What I need is not this. Damn it. Where are my other now? They were under another one of my masks. Okay. On what energy source do you sustain yourself? Mainly desperation. Occasionally blue. Those are my two stronger choices. Okay, first things first, before we go on, I need to check where we have an available ground that isn't taken up yet. Bottommost one. Oh, well, that's convenient. That is a lovely place for me to use, actually. Right here. I guess we could just connect the common ground top, but this one is just so much easier. Right, I think it should be connected. And it is GPIO 26. Convenient to keep in mind. Now, Python. All I need to do is just turn on GLD. Okay. Import RPI and GPIO as GPIO. Okay, so apparently pin is equal to LED? Wait, what? There's an LED function. That's really odd. 26? No, attribute LED. Yeah, I figured. Is it going to be pin? Well, now I'm getting confused. Or actually we can just import, oh wait, import GPIO 0? Ah, I see! Pin is equal to pin, no wait, LED. But we do need to do dot GPIO, right? Yeah, exactly. GPIO 0. Maybe don't misspell it. That actually worked, my goodness. Now if we do this, and if the LED lights up, that means it works. Would you look at that? That's brilliant. Okay. So. Delish. Now. We're going to what? Make a new folder. Call it fixed dev. Danny, you okay? What happened? Danny just almost fell over. I'm worried about him. Nope. Remember last time Danny talked how much effort it was to unclog him? Now cd fix it dev. Actually even better, code fix it dev. I will just make the whole process easier. Why do I need to set up a separate SSH connection? I just do not understand. Alright. Right here. We have it. Then what we're going to do is just turn on the Explorer. Like so. And just simply move the files. Do you think shorter streams will come for more viewers, or is it better like this? I don't think about that, Adam. I don't do these streams for views. I don't know. I feel like it shows if you go on my channel. Well, we need to wait for this to upload. That may take a while. Man, am I glad that I just took a break from waiting in order to wait, and whilst waiting I also am waiting. We're waiting for the animation, for the print, and right now for the files to move. What an interesting live stream this is, huh? Ta-da! It is actually working with magic. I really wish I could have more information. About how it's doing, because if I check right now the size of files, it's gonna take away from the upload time. So we need to wait. I like how you explain the simplest things, and then when it goes to something astronomically complex, requires base knowledge from a lot of areas, you go by like Einstein. It is a bit of a meme at this point, the fact that I explain things like functions in videos about particle physics. Okay, but first things first, here's what we need. From this mask, actually. I need to move this to the side. No, there are so many things in the way. Right. This off. This off. Okay. Now what we need to do is take off the LED strip from the top, simply because that LED strip will be annoying. Always remember, kids, it's important to have a clean and organized workspace, because if it's too cluttered, then you cannot find the tools you need in order to work on what you need to work. So always have a clean workspace in which, if you need to find a screwdriver, you're not going to spend too much time looking for a screwdriver. Okay, here's the pickle. This wire, and this wire, they're all soldered. We don't actually need them soldered. We need the opposite. So, why did you just turn off? Oh, now is not the time for you to turn off. Oh, I don't actually know if the backup battery is charged. Oh, this is bad. Oh, damn it. Oh, that is not good. That is not good at all. Come on. Okay, I hope this time it's actually has some battery in it. Great, that's great. That was just phenomenal. So I guess. I'm finding watching your character move while you panic is quite satisfying too. I don't panic, come on. I'm completely sane. Okay, this cable right here has to go, this one right here, and this one right here. All three of them. Why is it all sound so yellow? This is going to be extremely annoying, but here I go. This is the data line. And these two are the power sources. Oh, this cable is strong. Okay, there we go. Then it's just a matter of unscrewing it. Now this mask will become utterly useless from this point on, simply because, well, it's falling apart. Well, it was fun while it lasted. There we go. This is what we were actually after. That's because these two lines right here, those are the power lines, and this line at the end is the data line. Which means effectively that we need to solder this one to the common ground, shouldn't be difficult. This one to a live. I'm not quite certain if 3v3 or 5 volts actually, I will need to double check on that. Okay, let me just... What's behind Visual Studio Code? I wanna know. It's the rest of my desk. What did you think it was? I'm home. Alright, welcome home, class. Okay. This is not needed. Oh, let's see how the upload. It's still uploading. You are ridiculous. You're having a piss. Unbelievable. Absolutely unbelievable. And I won't even get like an estimate of or how many bytes you've sent already, because I can check for myself how large that folder is. It should be, I think, 2 gigabytes, something like that. Let me see. Properties. Yeah, it's 2.5 gigabytes. This is. I could have just taken out the SD card and moved it manually. But at this point it's a sunk cost fallacy. This is gonna take ages. What are you working on? I'm working on my mask. My naked mask. I'm really close to being finished. Really close. I'm just waiting mainly for one... Oh, it moved. Brilliant. Yes. That's good. Okay. Now this could be running a bit slow, but I'm going to test it regardless. Python 3. Basic speed recognition. First of all, it failed with Vosk. Okay, pip install Vosk. Oh my goodness, I'm going to strangle you. Considering how slowly it's running, I'm worried. Oh, I am fine. I am fine. How do you do it in Debian? Pip X install. What is pip X? Yeah, come on the phone. No shit. I'm fine. I'm okay. I'm okay. I'm okay. I'm okay. I'm okay. I'm okay. Hey, I'm okay. I'm doing fine, everyone. Did you hear me? I'm doing fine. Now stop asking. It's okay. It's okay. All right. Vosk. Yes. It absolutely does not work. But it's okay. Still, this environment is externally managed. To system, I try app install. The package you are trying to install. That didn't work. I don't get virtual environments in Python. I don't get why they are so important. I don't understand. What are you doing? I'm fine, I already said that! Okay, doesn't matter. It's fine. Alright, yeah, screw it. You know what? Piss it all away. Python 3. Then this. Okay. This appears to have created a whole bunch of things, and then what? Oh, how did you activate it? Was it the bin activate? I don't remember. It was bin activate or something like that. Never mind. The command is still running, still creating the environment. I should hope that I didn't mess up the measurements, because if I did, this is going to be quite annoying. Nope, this seems to be correct. Now this will have to go over like this, which it clearly doesn't have the range to do. I don't even care. Pointers. We have lights. Okay. Each one can have a different version, use different adapter. Library version management. But I don't care! I'm going to it's my machine! I am going to use the same exact library version across the entire system! Let me! I'm begging you! Okay, was it the bin activate? No, it wasn't the bin. Oh wait, it was bin pip install Vosk. Oh, if you have a problem with me now, I am going to... There we go, you better. Okay. Bin Python 3. Basic speech recognition. Run this bad boy. No more name Python. I am going to strangle you with my bare hands. Pi audio. Okay. So far we got to the third package. If JSON won't be included, commands actually, yeah, the commands doesn't have to be there. And pill also doesn't have to be there. We don't have to open the image. Yes. So far, so correct. Not you, class, not you. Failed to build wheel with. I'm sorry, what now? I'm sorry, what? Sorry. It's okay, it's okay, it's okay. This is just. I just need to install some libraries. It happens. Debian port audio H. I just need to get the libraries. It's fine. Port audio 19 dev. It's okay. Alright, I'm fine. Sudo apt install port audio 19 dev. There we go. All we need to do is, it makes sense. It's a development package, right? Why would it be included by default? You don't need it. It's just for people who develop. And not everyone develops by default, so it makes sense. Yes, download. It's fine. I'm fine. I'm okay. I'm doing just fine. I'm doing just fine. Okay. Well, I'm sure I'm enjoying my time off from work so I can work some more. Okay, now install PyAudio again. Should be easy, you already tried it. It's fine. Okay, installing build dependencies. See, it's fine. Building wheel. That's great. Great. Successfully built. That's brilliant. Now, try running the program again, okay? I got to loading the Vosk. We got through the libraries. Oh. Please. Please. If it works, it's going to be so incredible. Okay, as it's loading, I'm gonna go and check up on the camera. See what's the power doing, maybe it's dubbing. Nope, it seems to be still going strong. That's great. Okay, I'm back. What did I miss? Tell me and tell me now. It's still going. I mean, it makes sense. It took like solid minutes to work it out on my computer, and it's like a couple orders of magnitude stronger than. Oh, that is. Oh, is that bad, eh? Alright. That is quite bad. So apparently it's taking up so many resources that it's. Oh no. Okay, it's fine, I think. We might need a lighter Vosk module, which is a problem. Because I think lighter Vosk models might have problem running. I'm using this one currently. Lightweight. This one is for Raspberry Pi, so I guess I should have used this one. Whoops, sorry about that. I make it. Are you programming a program? Yes, I am programming a program. This should be fine, because effectively all we need to do is just, well, upload it. Which, in all fairness, okay, that does not appear to be happening. How about this? There we go, yeah, copy. This one is only 40 megabytes, not 2 gigabytes, so this one should be a flash. Now right here we're going to have, instead of Vosk module, we're going to have Vosk module small. It might be worse in accuracy, which isn't great because the microphone is also worse in accuracy, but it's fine. It happens. Actually, call the recognizer. What is this value? I'm going to check it on my own. Args any. You're not gonna elaborate on that. What is that number? Just a number. Right, no, it's fine, I get it. Sometimes we just have numbers. Alright. I'm gonna do the thing that's not the definition of insanity and just do the same exact thing again, expecting something to change. Yeah. There's every number is lower, which is good. Good for me right now. Loading. Oh! Oh! Invalid sample rate? Huh. That's a curious thing to die on. Alright. Import Pi audio. Capital A? No. Oh, because you need to. Oh, piss off. Import Pi audio. Repeat them explaining change. Exactly, yeah. Alright, P is equal to Pi audio. Pi audio. Now. Huh? I know. Oh, that's great. The Jack server is not running or cannot be started. It's fine. It's from one problem to another. Raspberry Pi audio in Python. I need an input stream to be more specific. Already have that. My game. I don't want to play the opposite. Playing is easier. Recording audio. That is not quite it, but that could be close. Okay, audio, yeah. What if P failed? Print P. It is a Pi audio object, alright. Get device count. 7! Consider me shocked and surprised. This is the top one. Is most definitely the top one. Open. Okay, so we open it. Format. Yeah. Maybe it genuinely was just the wrong sample rate. Let's try this. Invalid sample rate. Invalid sample rate. That's okay. Let me have a think. What's the program about? Long story. It's complicated. Number of channels 1. Can it record in one channel? Well, I'm gonna assume yes. Input device index. That's what I might need to do. Input device index. And let's do 0. Alright. My sound card isn't working. It's Python. Yes, it is Python. kind of sample rate am I supposed to use here? Because in my case, I most definitely want to use this one. Which, correct me if I'm wrong. Please do correct me if I'm wrong. 0. It is the 0. Yes. Can I just, like, leave this all implied? Can you figure out for yourself what, you know, RAID channels and format? I would really rather not, because I don't know what kind of input or output stream. Oh, I'm gonna lose it. Input true. Invalid sample rate. Raspberry Pi 0. Microphone Python invalid sample rate. Solution wide, not sure why it works. Oh, info, device info by index. Wait, what? No. What is the info by index? Default sample rate 4800. Fine. Oh my goodness, that worked. Okay, brilliant. No, 48. I didn't think it would work with 48, considering how, if I remember correctly, when I was checking the microphone, it very much couldn't handle 48 kilohertz, but hey. What what am I supposed to say? I'm just the guide who built this thing, right? Like, what would I know? Run the sucker. I don't like the fact that the stream opening happens after we load in Vosk, because loading Vosk takes much longer. Oh my goodness, wait, what? Hold on, it's listening. Never mind, input overflow! Oh, brilliant. It's fine, I can figure this out. Raspberry Pi, Pi audio input overflowed. Yeah. Secure parameter exception no overflow. Set this to false. That doesn't feel like a great solution. Correct me if I'm wrong. That doesn't. Nah, fuck it. Why not? Just run it again. We don't. Just let it overflow. See if I can. Okay. Now, it's time for the big test. Are you ready? Test! 1, 2, 3, test! Come on, still talking detected. Alright, test! 1, 2, 3, test! Please, I beg you. Okay. It struggles. Oh shit. Oh shit, it struggles. It didn't detect anything. Oh, this is not great. Alright, in case you can see, this is what it got from me saying 1, 2, 3. And I'm suspecting that this is not the fault of the Vosk model. We can test it easily. Copy folder. There we go. Right here we can just do model small n US. And we can just run it. Test 1 2 3. Test 1 2 3. Yeah, it fucked up. Terminate. Terminate. Oh, that, you see, that detected. That's great. So the model is fine. The problem we're having is the mic, which is bad because, trust me, the model being the problem would be so much easier to fix. Okay. Let me just see into here why this would overflow. Encounter this issue. It means that between previous call and stream read and this current call, data from the stream was lost. Buffer filled fast and you cleared it. That's the problem. We're not getting the full. Damn it! That's not great. Let me repeat it. Okay. Pi audio record an audio file. Because the issue then appears to be that we. What do you record? Test mic. Pi. Hi there, Ash. Make if you are bored, you can solve the ith root of -1 without natural log. It's so interesting. I am very much not bored. And if it's the opposite. I am very much invested in what I'm doing right now. Okay. We open this as a stream, we record frames, range chunk records the day stream read, chunk and data, stop stream terminate, and wave output file name. Right here we just have test channels 1 set sample rate well 48. It's the sample rate, that's the problem. Oh no. Oh no. Oh no. I don't know what chunk has to be. I'm just gonna say two for now because I haven't got a clue how much that should be. Record seconds. Let's do 2 because I feel like I'm gonna fuck it up. It's sample size format. I just comment this out for now. Pi audio is not defined. Of course it isn't. Test 1 2 3. Test 1 2 3. June Pi audio. That's what you broke on? I'm fine. I am so fine. Don't terminate it. See if I can. Test 1 2 3. Test 1 2 3. Wave is not defined. I am. Why is this wave not open? I'm sorry. What kind of code did you get? You need to import wave threading and sys. Why the threading? Oh no, never mind. Pi audio and wave. I've okay. That might have been a slight, you know, I might have just, it's been a long day. Test not defined. I'm fine, I'm okay. It's been a long day. Test.vav. Test! 1, 2, 3, test! Sample width is not specified. Ooh, I'm going to commit a war crime. Can I just do 2 right here and just not care? Test! 1, 2, 3, test! 1, 2, 3. Sample width is not specified. Okay, it's fine. Why is audio there? Oh my goodness. On the very beginning they do this. Test 1, 2, 3, test 1, 2, 3. Finish recording. Let me see it. It's 1 second, but you know what, whatever. I don't even care. Why is it fast? I'm guessing it's because of the chunk. I did set the chunk because I did set the chunk absolutely randomly, so I don't know what I was even expecting. Let me see. Doesn't one make this better? No, one doesn't even make it playable at all. Now the question is, does it not make it playable because it didn't record? Does it make it not playable because of cache or something? It appears to be cache, alright. Just set the chunk to 1 again. Test 1, 2, 3, test 1, 2, 3. Let me see. How is it? Didn't make this better. Can I set this? Is it because of the chunk? Couldn't it be because of the chunk? Honestly, the rate is a crime because I know that it cannot handle that kind of rate. If I set it to 10,000, it's just going to break. Right? Yeah, invalid sample rate. How do I get around invalid sample rate? I don't know. How you doing? Ah, Pi audio invalid sample rate, but actually it's really fucking valid. I know because that's the sample rate. You know what, this actually might not be helpful to the search. Invalid sample rate, let's just try that. How do I notify sample rate in Pi audio? Yeah. Okay. Is format supported? And then you need to add in, this is ridiculous. There's no way. You know what? Fine. See if I can. We're just gonna check every single sample rate to see if it's supported. Test rates.py. This import Pi audio, then do the thing that we do normally. Great, splendid. This. Then if this is supported, then just print me an F string. No wait, no. Here's what we're going to do. For I in range, and the range is going to be 48,000. If this, then print I is supported. And right here we're obviously gonna apply the I. And then we're gonna just run it! Test rates. I cannot even invalid sample rate. Well, I guess then we know, huh? It's taking. Wait. Supported frame rates. Supported to devices. Ah, line 49. Where's line 49? 49. Never mind. There is. Okay. I have been lied to and deceived. Oh no, section that says the line 49. Sure, you can use the Python is formatable method. I very much cannot. Sound device. I don't have sound device. Bin pip install sound device. I effectively need as low of a sample rate as possible. Okay, so I told you choose dynamically, we're moving input device index. I am going to lose my mind. I am just straight up going to lose my mind is what's going to happen. I don't have much to be lost, but I am going to lose my mind. Can I reduce the chunk size actually at least? That would be something. Chunk size. Because that could help us with the overflow. I don't know, 64? That would be nice. Let's try it. Oh yeah, and sample rate won't work, it has to be 48,000. Test mic. Test! Oh my goodness. I can't spell keyword argument chunk size. Pi audio set chunk size. Frames per buffer. No wonder 8,000. No wonder it's overflowing. Test 1, 2, 3. Test 1. Okay, there we go. That's far as far as it could go. All right. Well, let's try it now. Maybe with I don't know 32 frames per buffer. And 32 right here, I guess, because I think those are the numbers. Are you gonna read the chat? I am reading my chat. Basic speech. Okay. Just don't crash. I do have the exception with no overflow set to false, which is probably a really bad idea. But still, I'm gonna try it and I'm gonna hope for the best. Hey, 1, 2, 3, test. You detected blue out of everything. Test 1, 2, 3. Test 1, 2, 3. Anything? Nothing? Not gonna even. Just watch. Okay, it's fine. It's fine. It's fine. I'm just gonna set you down. Let me turn you off. And then I'm going to have. I don't know. Hi there, Marco. How you doing? It's fine. It's fine. Just watched it all crumble. It's okay. It's okay. The issue we are having is that our microphone cannot handle the sample rate we need. And for some reason, Pi Audio just refuses to work with a lower sample rate. Why? Really good question. Invalid sample rate. Why is it invalid? Just, I know for a fact it works. What is Snowboy? With higher, I'm having issue with lower sample rates. Oh, it's also Raspberry, that's brilliant. Wait, what happened about your sponsors? What do you mean what happened about my sponsors? Your last few posts. Yeah, but what do you mean what happened with them? Try recording playback, see if it works properly. It does work properly. I have a file to test that. The issue I'm having, Marco, is not that the microphone doesn't work. I've tested that independently a couple of streams back, and I can actually record with 10,000 sample rate. The reason why I chose 10,000 is because, if I remember correctly, what was the name of the microphone? It was the MEMS microphone. Which one? INP. No wait, it was MEMS INMP. I don't remember the name. Whatever microphone. 441, obviously 441. And in the datasheet, give me the datasheet. 441 datasheets. There we go. Flat frequency response from 60 Hz to 15 kHz. Right? Yeah. I imagine what happens is that the microphone is recording it. Actually, wait. What are you going to do with the money? I'm gonna pay my rent. That's what I'm gonna do with the money. Possibly even my internet bill and electricity bill, if I'm lucky. Industrial sound. Somebody must be double the frequency of the sound recorded. But even then, that's 30 kilohertz. And I need 48 for Python to work. I mean, the issue I'm having is that the Pi Zero simply cannot upscale it. What do you mean upscale it? I want to downscale it, if anything. Record at 24 double. No, I need to record it at 48 because Pi Audio won't let me get any lower. Whenever I try to set any kind of lower rate, it just gives me an error of invalid rate. I can show you if you want. Right here we have sample rate of 48,000. If I set it to 47,000, hold on, Python 3 test mic. Invalid sample rate. Only 48 works. Downsample then. My issue, Marco, is that, well, as far as I'm aware, I'm doing a fair bit of guesstimates here. This is not easy. But try 40 for 100. Oh, you think it's just abiding by standards? That could be it. No, still invalid. Not every sample rate supported their discrete values. Yeah, but what bugs me is that in this case it's clearly not supported by software. That's an arbitrary an arbitrary roadblock. I can do R code. If only I remembered how to record stuff. Where is my cheat sheet? List. Cheat sheet, right. R code this, right, there we go. I can do this with, wait, 48. Did I drop it down to 10,000? Yeah, there we go, you see? I am right now recording with 10 kilohertz. Stop it. Unexpected system call dies to be expected. Yeah, there we go, you see? I am right now recording with 10 kilohertz. It is really quiet, but I mean, you can hear it. And the issue is that if I record at 48 kilohertz, then the stream gets overloaded, and then it starts just overflowing. And once it starts overflowing, then it going to Vosk, it gets all messed up and just detects the color blue for some reason. Have you considered using Gradlu Clean? I have no idea what that is, Olo. Let me have a think. How do I can. How can I test this better? That's the better question. I mean, right here we still don't have. Wait, if I frames per buffer, we already have frames per buffer at 32. Maybe we reduced it too much. Oh no, this is gonna suck. What type of data do you need for the program? I need data stream. Right here, the line. I should also remove the exception on overflow false. I feel like exception on overflow might be actually quite useful to let me know something wrong is about to happen. Basic. Run this bad boy. Okay. Please don't overflow in the first 2 seconds. I would really appreciate that. Test. 1, 2, 3. Test. Damn it. Okay. Okay, it's something. It's not something. Input overflowed. Right. Quick. Input overflow very much suggests that it is a hardware issue of just not enough computational power, which is bad because that's not something I can fix. As a processing, most computers can't really handle under 128, and even that's level. Oh, what do you mean most computers can't handle under 128? Oh, under 128. Oh, so you think I should say like 256? Wait, oh no, I already have 256. Again, this is a data with stream rate currently on the Docker stream function videos. Let's try to frames. For the overflow and just return what we have, you can apply the patch below, which will cause stream rate to ignore output underrun and input overflow errors from port audio. Okay. Make this behavior customer. Oh, that is quite a patch. Only for 19, come on. The smaller the buffer, the more often the CPU must pull from the microphone. But in this case, I'm kind of running into an issue of buffer being too big. I mean, I can set it back to 8,000, I suppose. The problem being that it also overflowed with 8,000. There we go. Isn't that right, my beloved fix-it? Input overflowed. Okay. On the read stream. The problem is input overflowing. Well, let's just go the other way. Come on. Come on. You good, buddy. I believe in you. I know you're small and I know you're struggling, but you can... Oh, well, I mean, that was something. It wasn't great, but it was something. Alright, spin that bad boy up, 100. That's 10,000 make it. Okay. In the meantime, as we're doing the silly thing, let me think if there is something better I could do with this. We could try a different... Oh, it actually is... It lives! Not well, keep in mind. Oh, that is idiotic. That is just straight up idiotic. The bigger the number you prefer, the longer it runs. That very much shouldn't work. Why? Genuine question, why? Is it because I'm sorry, what is overflowing? Doesn't make sense. Your buffer is really big, it takes a long time to record 100k samples. No, it doesn't make sense for another reason. On my normal machine, I did fine with a buffer of 8,000. It cannot be the size of the buffer. In this case, what must actually happen is the buffer size is delaying the overflow. Maybe it's because the 0 is like assigning it more memory simply to account for a bigger buffer? Oh. Either. I am so confused. I am so utterly confused. Wait, let me have a think. Which part overflows though? $1 million question. Input overflows. That is quite vague. Alright. The entire time I was assuming it was the buffer that was overflowing. In the previous call to stream read in this current call, data from the stream was lost. It could be... Okay, it could be because since it's trying to run the model, it takes such a long time to run the model that the buffer cannot fit in the gap in between each iteration of the loop. That would make some sense. Not a lot, but some. Before trying to fix that, let's try to test it. And the way I imagine we would test it is... Oh, that's not a great way to test it, but I don't have a better way. Right here. I'm just gonna wait for, I don't know, 2 seconds at the end of each loop. No, because we need active, right, yeah, we do need active. First, okay. Gave up on physics, how? Don't worry. I'm not really sure how this Python stuff, I did audio and C and embedded. Marco, I am also a C programmer and Python vexes me sometimes. Remco, I temporarily give up on physics to work on the mask and it's going great so far. It is working out for me just tremendously. You wouldn't believe the headache I'm having. Okay, it's idiotic, but let's test it. Test 1 2 3. Test 1 2 3. It's Yeah, it's we're sleeping for 2 seconds. That's to be expected. Yeah, that. Not this positive. Alright. Have a good masking. I am very much not Remco. I am very much not. Okay, let me have a think. Maybe what we need to focus on is trying to make the... Because here's the thing. Hear me out. When we are trying to record, to test the mic, the output comes out at twice the speed. Oh wait, hold on. Set sample size should be accounted for, right? Test mic. Invalid sample rate. I am going to strangle you to death. I don't care that you're a program. I'll find a way. Run it, test! 1, 2, 3, let's record. There we go, that's recording. Sample width not specified. What do you mean? Not specified? Wave open. What's this line then? Where's that line? What do you mean? It's okay, it's okay. You know what, let's just add it all in, because why not? Might as well. It's getting confused, might as well. It's alright, it's fine. I'm fine, okay? There non-type has no attribute set. It's fine. Is that applying on? I have no clue how Python notation works. This might be the problem. I don't think that's the problem, because it's never been a problem to me in Manim, for example. Yeah, exactly. If you would just be patient with me, then you would realize. Do I need to do it with like the with open business? Can I just do wave open, like WF is equal to wave open? Did you try reading less than the buffer size? Does it recognize more word from data fed only once in a while, or will you recognize only from the current buffer? Data fed once in a while will recognize only from the current buffer. I imagine it doesn't matter. Although I will be brutally honest with you, I haven't tested that yet. Test 1, 2, 3. Sample not specified on 2 lines. Okay, 2 lines down the line. Literally 2 lines down the line. I am specifying your sample width, alright? It's okay. It's okay. I'm not mad. I'm not disappointed. I'm actually furious, is what I am. But why can't you just go down a bit? It's okay. I'm going to just delete the file and then try again. I don't know, why not? Might as well. Because the thing is, I somehow... Oh no, you do open the file, you just don't... Name argument and then... It is... This is not my code, Marco. This specific part is not my code. You can see, because it has comments, I would never. Okay. Hold on, I'm consulting the manuscripts. One of these, right here, is the code I've used to... Damn, I'm good. This is the code, okay. Right here, it is doing... It is that's just, yeah, that is how it's doing. Wave, anything I missed? You know what? What am I doing? Just... Invalid sample rate. I am fine, I'm fine. I won't yell because I'm okay. I'm okay, actually. Invalid sample rate, of course invalid sample rate, because it isn't 48,000. Why would it be valid? Why would it be valid, huh? I don't even know. What even is? Are there any other numbers than 48,000? I've never heard of them. I've certainly never heard of them. I'm pretty certain 48,000 is the only number. Error occurred while loading this file. It's okay. Oh, output pi audio. Right, it's a different file. It's okay. How much data does the mode process at the time? I don't know. Why would it be valid, huh? I don't even... Okay. As you can hear, if you can hear it, because it might be a bit quiet on stream. Why would it be valid, huh? I don't even know. What even is? I had a math test, I wrote 48,000, they failed me. They don't know mathematics. 48,000 is in fact the only number. And you can quote me on that. But it seems to be recording fine. So you know what? Let's just copy this setup right here. And let's just paste it in. And then let me pick it up. Move it as closer. Test 1, 2, 3. Test 1, 2, 3. How about now, huh? Can you maybe detect? You're listening, huh? Recognize text? No, you didn't. There is nothing there. Don't lie to me. What text did you and input overflow? Okay, that happens. Okay, you know what? I'm just gonna pick it up again. I won't yell. I'm calm. I'm fine. I'm just honestly so fine. It broke instantly. Okay, so 40. Yeah, screw the typical answer. 48,000 is the answer to the universe. Here's the thing. What we can do is we can just ignore the exceptions on overflow. However, this is not a great solution. Normally, this is kind of just like, you know, in GCC, just setting the flags to ignore the warnings. You're not actually fixing the underlying issue. All you are effectively doing is, but I'm still talking, it should be detecting it. It is very much not detecting. I am speaking into the microphone right now. 1, 2, 3. Can you detect a single word I am saying? And no, I won't count the D because it is the most common. I am going to lose my marbles, is what's gonna happen. It detected 1, not when I said it, but it did. I'm fine. What is the recognizer library? It is Vosk as the recognizer library. I am going to do something that's possibly quite dumb, and that is switch to the bigger model. I know, bad idea, I hear you. But hear me out. Oh no, I just remembered. No, never mind. Okay. No, cancel operation. Abort. Okay, well that was nice seeing you. I'm gonna Oh, is the SSH not replying? Yeah, color me surprised. I might just like turn it off and on, I guess. Something I can do. Oh, that is... It's fine. It's okay. Error timeout. Connecting with SSH time. Connecting with SSH timed out. Oh, really? Oh, who could have possibly foreseen? Well, to be fair, I don't know why I'm complaining. It's entirely my fault. I was the one who turned on the thing. It's fine though. It's okay. It's okay. That's not an issue. Maybe I could ask Tefta. I could ask Tefta to quantize the model for me. The big one. And see how accurate we can get the quantization. Or alternatively, what we could do is we could, but that would be idiotic. We could theoretically set it up on the Raspberry Pi 5. See if Raspberry Pi 5, well, but then why did I add the microphone in there? I could set up a stream, audio stream, from the Pi 0 to the Pi 5. Are you planning to add quantized language model to your mask? No. The quantized sound to text, speech to text. That's the one we're working on right now. Okay, here's plan B. What I could do is, I could put the speech to text on this, which I'm pretty certain could handle it. Then we could set up an audio stream from the 0 to the Pi 5. Pi 5 would do the processing. It would send back the data to the 0, and 0 would handle the mask. It's not a brilliant solution. So now the title, Mask Talking Back. When I said the mask was gonna talk back, I was planning to add some sounds and noises and beeps and boops. So that when I say something like, I don't know, fix it, self-destruct, it's gonna start flashing red and doing the sirens, right? But no, it's not. If you can't run the model as real time, your audio buffer will always overflow and you lose data. I am aware of the problem, yes. Hence why I proposed the Pi 5 idea. The only reason why this halted me is because, well, it won't be easy. It won't be exactly an easy fix. First of all, I would need to power 2 separate devices at runtime, one of which won't even be attached to the mask. Second of all, I don't like networking, so I would need to connect this little bugger to this little bugger with networking. Something I'm not good at. I guess that's the only option. Like, I don't mean to be that guy, but it's not exactly as if I have a plan B. The microphone should be in the mask. Yeah, and it very much will be. What do you mean? I don't quite get what you mean. Because the microphone very much will be in the mask. Well, I can put it in the mask right now. The only thing is that I got sidetracked with software. Does the mask have a display to show what you're saying? No, it doesn't. It does not. The mask has only LEDs, microphone, and an audio amplifier. So all the mask can do is it can give me light, it can give me multicolored light, it can listen, and it can play audio. And that is all the things that mask can do at this moment. What are you doing with the recognized speech? Well, so far, nothing. I'm trying to recognize speech. That's step 1. I can't really do anything with the recognized speech if the recognized speech doesn't work. That is the issue we're having, Marco. The reason why I'm not doing anything with it is because it's very much not recognized speech. If you want me to prove that it's very much not recognized speech, would you? Wait, is it still running? Oh, you are unbelievable. Yeah, you know what? I won't, because what's the plan if it worked? Well, if it worked, then I would just do anything. As in, well, first things first, as a test, obviously, I would connect through, comically enough, a motor driver, these bright LEDs, and the other LEDs, those are simple because those have a data line. And first I would test it by adding basic commands like, turn on the lights, set light color red, stuff like these. Then once that is finished, I would also implement playing sounds, which also works because we've tested the audio amplifier with the speaker that is right here. I know you can't see it, so let me just... There we go. Then after that, what I imagine I would do, the next thing is probably the Discord bot, for example. So I would do like voice activated Discord commands just for the funsies, the shiggles, And then what is my oyster? With this is Raspberry Pi 02W, which means it has wireless connection, as you can clearly tell, which means whatever I build from then on, I can just add wireless connection to. I can connect it to the system, and then I can have the mask controlling it. Smoke is dangerous. Smoke is bad. Can you lift the camera? What do you want me to lift the camera for? Don't smoke. Can't tell me what to do. The pipe helps me think, okay? Yeah, no, I think that's the only way. I need to stream between these two devices. That is actually adding a pretty significant... That's a pretty significant detour from my plans. But hey, at least more content for the video, am I right? I think that will be it for today's stream. I am exhausted. I am just straight up exhausted with this. We didn't even get to assemble the mask. We'll either do that next stream or I'll do that in between the streams. It doesn't really matter. I'm gonna go... what's even more annoying is that I'm not even gonna go to rest right now. I'm gonna go work on 3 separate videos at the same time. But it's fine. Do you stream every day? No. Marco, don't be ridiculous. I don't stream every day. I stream like twice a day. I wish I was joking. I really do wish. I have nothing better to do with my time, so I just stream. Fun fact, in the top left corner, the number, that used to refer to how many days in a row I have streamed for. But after like 800 or so, I realized that they were taking a pretty significant toll on my mental health. So I promised So I basically said I no longer am doing them every day. That's why this no longer says day, only it says a number, like stream number. And then I just went on to do more than 1 stream a day. So many. Yeah. Oh well. I'm gonna go. I'm exhausted, and there's still so much work I need to do. No, something just exploded outside of my apartment. Well, that happens. We've all been there. And I suppose for now that'll be it. Thank you everyone so much for watching and have a great day. Bye!